Hello guys, this is me, Muhammad Ali from the Bright Light of Knowledge channel. This is the second episode for my embedded system series. I'm gonna teach you the difference between microcontrollers and microprocessors. Let's get started. First, I'm gonna share my screen. Let's get that slide. Yes, microcontrollers versus microprocessors. Bright Light of Knowledge channel by Muhammad Ali. But before we get to the comparison itself, let's know the points of comparison. First of all, integration. Is the system on something, or just lots of things in here, like your laptop, for example? Is the keyboard inside the screen and the mouse inside the screen with it? No, they're just external peripherals. And I mean by peripherals, just components. Like your keyboard is a peripheral, an input one. Your mouse is also a peripheral. Purpose. What task is it needed for? Architecture. How it was designed. Performance. Do we need it high or low? Memory. How much memory it needs? Does it need? Peripherals. What are the components used? Power consumption. Does it need too much power, or just power from a small battery? Cost. Will it be too expensive or too cheap? Operating system. Does it need an operating system or not? Applications. What is it used for? We will take lots of examples. But let's begin the tour. Integration. Integration. In microcontrollers, everything is on the chip, which is called, and you can basically say that it's a system on the chip, or an SoC. Like when you see the Raspberry Pi Pico, which is a microcontroller, it has pins, it has an USB input device, and has a lot of things, but all on the same chip itself. But what about microprocessors? The chip and the components are separated. You have the keyboard here, your mouse is here, the screen is here. They're not basically into one thing. No, they're just separated things, but are connected by wires. You get me? Now for purpose. Microcontrollers are used in only specific tasks, or is used in embedded systems. Like the Raspberry Pi Pico is used for just inputting a switch, or just outputting an LED. Like it's used for specific tasks. Like the task you're gonna make it. If you made an embedded system designed for a task, it's gonna make that task only. You know? Microprocessors. General tasks. If you have a Samsung phone, could you play games on it? You say yes. Can you calculate on it? Yes. Can you watch YouTube on it? Yes. That's what I call general tasks. Like lots of tasks. That's a big advantage for microprocessors too. Architecture. Microcontrollers use mainly Harvard architecture. Microprocessors usually uses von Neumann architecture. And you are gonna say, what is Harvard architecture and what is von Neumann architecture? This image is gonna demonstrate. Well, you see, Harvard architecture and the von Neumann architecture consist of three three things. Both of them: central processing unit, or the CPU, the memory or the ROM, the data memory or the RAM, program memory and data memory. Data memory is the RAM, program memory is the ROM. Harvard architecture used two separate address buses and data buses. so that no, there will be no communication interruptions between program memory and data memory. Like, you have two things here. And this is mainly good because if the program memory wants to deliver to the CPU and also the data memory wants to deliver to CPU, if they did it at the same time, no interruption occurred. But it's also too expensive. What about the von Neumann architecture, you ask? Well, it's actually way simpler. The CPU, and the RAM and the ROM have one single address bus and one single data bus. Well, you might say, that will cause some errors to happen. Yes, that will cause errors to happen, but it's usually very, very cheap. Microprocessors use the von Neumann architecture, while microcontroller uses the Harvard architecture. Now, performance. Microcontrollers. The performance is usually measured by the clock speed, and I mean here by clock speed is when it is the period where it takes to deliver something. Like, how am I supposed to demonstrate this? Okay, so I have some data and I want to send it to this device. The clock speed here represents how fast the device could check for that data. Like, it checked once, then it cut off this part. Then it checked again and cut off this and got off this part. It checked again, cut off this part. It checked again and got this part. Basically does it until it gets all of the data. But there are some types of chips that could do it faster, which, by the way, are microprocessors. Let me just put the charger. Okay, now let's proceed. Microprocessors, their clock speed is in gigahertz. Gigahertz here is just the frequency measurement unit, which measures how fast does it get the data. But the microprocessor might take a shorter time. Like, it gets the data and then reverse back. And it gets the data and reverse. See? Get all of the data in just 2 chunks. The microcontroller could get it in 5 chunks. That's just a demonstration. As I said here, clock speed in gigahertz. Hertz here is just the measuring unit of frequency. Memory. Microcontrollers relies only on chip memory, which is from kilobytes to megabytes. Doesn't need much memory. What about microprocessors? They need external memory, which is from megabytes to gigabytes. Well, you might say, gigabytes is too lame. There are terabytes. Yes, the external memory might reach terabytes. I think the highest was 2 terabytes or 4 terabytes, but I just don't know. You could tell me in the comments. Peripherals. Peripherals are just the components that are inside the chip itself. Microcontrollers has many chip peripherals. ADCs, which are analog to digital converters. It converts something analog, like the light, like to a digital signal. Timers, input output ports. Input output port are just the pins that are connected. Microprocessors, they don't need chip peripherals. They rely on external peripherals like your keyboard, like your mouse, like your screen. Yeah, lots of things. Power consumption. Microcontrollers, they need low power consumption. They might rely on a power consumption from a battery or 2 batteries, 5 volts. They don't need too much power. What about microprocessor? They need high power consumption. When you see gamers, they have like a big computer with big power supplies. That's basically high power consumption. And it'll also result to let you pay the bill. If you don't want to pay the bill, just get a microcontroller. No, I'm just kidding. You can get whatever you want. Cost. Microcontrollers, their cost is low due to the integration of the components. But what about microprocessors, you say? They have a high cost due to external peripherals. Like the microcontroller has some ADCs and timers and input-output ports. You could just get that with just a few bucks. What about microprocessors? No, you require the microprocessor itself. You need the keyboard, which is expensive. Not really expensive though. You need a screen, which is too expensive. You need a mouse, which is also a couple bucks. But this will definitely add to something like $1,000, $2,000. You get me, right? Just using examples so you can know which one to choose in the real life. Operating systems. Microcontrollers runs on a simpler OS or doesn't even need an OS. The microcontrollers don't need OS because they don't need too much power. Like the OS consumes a lot of power. But what about the microprocessors? Requires a full-fledged OS like Windows or Linux. When you see when you see your friend have a computer, he uses Windows 11, Windows 10, whatever, uh, Linux Debian, whatever. This is called a full-fledged OS, which means it, it has high performance. The applications for microcontrollers used for IoT devices, remote controllers. These devices mainly don't need too much power. That's why they are useful. That's why microcontrollers are useful for these. What about microprocessors used for smartphones, your PCs? Like your smartphone and your PC consumes a lot of power, and I mean a lot. Here is the resource of the image. And the bonus part, I'm gonna ask you a question. Embedded system engineers use microcontrollers or microprocessors? Answer in the comments. I hope you liked the video, and goodbye!